All right, looks like we're diving deep into Entity Framework Core today.
Definitely a favorite topic of mine.
It's a powerful tool, that's for sure.
Yeah, and I feel like there's always something new to learn with it.
So much depth.
Yeah,
right.
Exactly.
And whether you're prepping for an interview or just wanting to really up your game with data access in .NET, this is the place to be.
I couldn't have said it better myself.
Okay, so let's jump right into it.
Sounds good.
Let's start with the fundamentals, those CRU'd operations.
Yeah, you gotta have those, Darrow.
Create, read, update, delete. How do those work in EF Core?
Well, the core of it all is your DB context and those DB set properties.
Oh, DB context, the heart of EF Core.
Think of it like your session with the database, you know?
Got it.
And each DB set, well, that represents a collection of your entities, a specific type.
So, like, if I have a customer entity,
You got it.
I'd have a DB set of customer in my DB context.
Exactly.
Okay, that makes sense.
To create a new customer, you would just add a new customer object to that DB set. You'd use the add method. And then to actually save those changes to the database,
Yeah, make it real.
you call save changes on the DB context.
So it's like saying, hey, DB context, I made some changes. Go update the database.
That's a great way to think about it.
Okay, that makes sense for creative.
Nice and straightforward.
What about reading data?
Reading.
How would I get, say, a list of all my customers?
So EF Core, it really leverages the power of LINQ.
Oh, LINQ, love it.
Yeah, it lets you write those queries against your DB sets.
Mhm.
You can filter, sort, you name it.
Very intuitive.
It's almost like writing SQL, but you have that type safety of C#.
So I could get all customers from a specific city,
Absolutely.
or maybe all customers who've made an order in the last month.
Exactly, all through LINQ.
That's pretty powerful.
And updating data is even smoother.
Oh.
You fetch the entity you want to change,
Yep.
take your changes to its properties, and then boom.
Hit it with that save changes again.
Correctly.
Smart.
EF Core, it tracks those changes automatically.
Oh, wow.
So it knows exactly what needs to be updated in the database.
So it's not like I have to tell it what's different.
Nope, it figures it out.
It's very cool.
And deleting, just a straightforward.
Okay, good.
Remove the entity from your DB set, use remove.
Okay.
Then, of course, that save changes to sync it all up.
So really, it's like all these operations follow a similar pattern.
You got it. DB context and DB set are your main tools.
That's super helpful.
I'm glad.
So we've talked about DB context.
Yeah.
We've talked about DB sets.
Like the essentials.
What else is there to know about DB sets? It seems like they're really at the heart of working with entities.
They really are.
So what's their role? Big picture.
Think of a DB set as your gateway, your access point to a specific collection of those entities.
Okay.
And it's all managed by EF Core.
Makes sense.
It's how you query, it's how you interact with that data in the database.
So essentially, each DB set
Yep.
represents a table or a view in my database. And anything I do with the deep set
Uh-huh.
ultimately translates into SQL commands,
Right.
which EF Core then runs against the database.
It's the bridge between your code and the database.
Okay, starting to see the big picture now.
Good.
We've covered the basics of CRU'd operations.
Yeah.
And we've dived a bit deeper into DB sets.
Foundations.
Now, I want to talk about something slightly more complex.
All right, bring it on.
Composite keys.
Yes, those multi-column keys.
Always a fun one.
How to configure them in EF Core, right?
Exactly.
So there are a couple ways to do it.
Right.
You can use those data annotations directly in your entity class.
Annotations.
But for those more intricate situations, you have the Fluent API.
Fluent API, I've heard good things.
It's super powerful.
So why would I choose Fluent API over annotations for composite keys?
Well, annotations, they're great for simple cases,
Sure.
but Fluent API, it gives you that fine-grained control.
I like control.
It's all about configuring that model precisely how you want it.
And where does this configuration happen?
In your DB context,
Oh, for worth.
you override a method called onModelCreating.
On model creating. Got it.
And that's where the magic happens.
So using Fluent API, I can define those composite keys,
Yeah,
maybe set up relationships between my entities,
absolutely.
even configure indexes if I want to get fancy.
All of that and more.
It's like having a toolbox full of options.
Exactly. You're the architect of your model.
I like that.
You have the power.
Could you give me a concrete example of how I'd set up a composite key using Fluent API?
Sure. Let's imagine a table, maybe for students enrolling in courses.
Okay, classic example.
You'd have a primary key,
Uh-huh.
but it's not just one column.
Right, it's a
The
combination.
combination of the student ID and the course ID.
Makes sense. That way, each enrollment record is unique.
Exactly.
So how do I tell EF Core, hey, these two columns, they make up my composite key?
In that on-model creating method,
Okay.
you would use the Hosky method, and you specify the properties that form that key.
Okay, so it would be something like,
modelbuilder.entityEnrollment.Hosky new studentide coursified.
so I'm telling EF Core that the combination of studentide and courside,
Yep.
that's what uniquely identifies an enrollment entity.
Precise.
Fluid API, it's pretty neat.
It's a powerful tool.
So you're essentially defining the blueprint of your database schema
You got it.
using C# code.
Clean and declarative.
Yeah, this is all making a lot of sense.
I'm glad to hear that.
We've covered creating data, reading data, updating, deleting, and even how to define composite keys with Fluent API.
Yeah, we're making progress.
But what about when things get a little messy? What happens when you have multiple users all trying to update the same data at the same time?
The dreaded concurrency issue.
That's got to be a recipe for disaster, right?
It could be, but luckily EF Core has our back.
Oh, good.
It uses something called optimistic concurrency control.
Optimistic, huh? Sounds hopeful.
Basically, it doesn't lock the data right away.
Um,
Instead, it checks for any conflicts, but it does it right before that transaction is finished.
So it's like a last-minute check to make sure nothing's gone wrong.
Exactly, and if it finds a conflict, it throws an exception.
Oh, okay.
Then it's up to your application to handle that gracefully.
So it's like a safety net. It prevents those accidental overwrites and keeps my data consistent.
You got it. And to do all this, it uses something called concurrency tokens.
Concurrency tokens, what are those?
They're special properties in your entities.
Okay.
And EF Core, it keeps an eye on them, watching for any changes.
It's like a watchdog, making sure nobody's messing with the data.
Exactly. And by comparing these tokens, it can tell if the data's been changed by someone else.
Yes. So if I'm working on some data and someone else comes along and updates it,
Mm-hmm.
EF Core will stop me from accidentally overwriting their changes.
Yep, you'll get an exception.
That's a relief. I can see how that would be so important in a real application.
Definitely crucial for data integrity.
Okay, so we've got concurrency control covered. Let's move on to another big one, inheritance.
Inheritance, the classic OOP concept.
How does that work in the database world?
EF Core's got a few tricks up its sleeve for that.
Okay, I'm intrigued.
It offers 3 main strategies for mapping inheritance to your database schema.
3 strategies, all right.
We've got TPH, table per hierarchy.
TPH,
Then there's TPT, table per type.
TPT,
And finally, TPC, table per concrete class.
PPC. Okay, lots of acronyms.
But they're not too complicated once you break them down.
All right, let's break them down one by one.
Sounds good.
Let's say I'm building an app to manage, I don't know, a zoo.
A zoo, I like it.
I've got all kinds of animals, mammals, birds, reptiles,
A diverse bunch.
each with its own unique characteristic.
Absolutely.
So I could have a base animal class
Yeah,
and then more specific classes like bird or reptile that inherit from it.
makes sense.
So with TPH, table per hierarchy,
Right.
what happens?
All those animals, they all go into a single table
One big table.
called animals.
Animals.
Right.
Simple enough.
But there's a catch.
There's always a catch.
We need a discriminator column.
A discriminator. What's that for?
It tells us what type of animal each row represents.
Ah, so it's like a label telling us if it's a lion or a parrot.
Exactly.
Okay, so it's efficient for querying,
Yeah, everything's in one place.
but it could lead to a lot of empty columns, right?
You got it.
Like a wingspan column for a reptile? Doesn't make much sense.
Not really.
So TPH, it's like putting everything under one big roof.
A one-size-fits-all approach.
What about TPT, table per type?
With TPT, each animal type gets its own table.
Separate tables, okay.
Right, you'd have your animals table for those common attributes.
Like name and age?
Yep. And then a birds table with wingspan.
And a reptiles table with maybe a venomous flag.
Exactly. And
Wow.
all these tables are linked by foreign keys.
So it's like a family tree showing the relationships between them.
You got it. A more normalized approach.
Okay? And TPC, the last one.
Table per concrete class.
What's that all about?
Now, with this one, each concrete class, like Eagle or Python,
The specific animals.
they get their own table.
Okay.
And those tables contain all the attributes, even the inherited ones.
So no need to look back up the family tree.
Exactly.
But doesn't that lead to duplicated data?
It could, yeah.
So it sounds like choosing the right strategy
Yep.
depends on the situation, weighing the pros and cons.
You hit the nail on the head.
Performance, normalization, data duplication. It's a balancing act.
Exactly. No one-size-fits-all answer.
Right. This is all fantastic information.
Glad you think so.
We've covered so much ground already.
Good start.
CRUD operations, DB sets, Fluid API, concurrency, even inheritance.
The core concepts.
What else should we hit before we wrap up this part?
Let's talk transactions.
Transactions, okay.
It's all about keeping your data safe and sound,
Essential stuff.
making sure everything happens as it should.
So if something goes wrong,
Yeah,
we don't end up with a half-updated database.
exactly.
Okay, tell me more.
So a transaction, it bundles up a set of database operations
Yeah.
and treats them as a single unit of work.
Like an all-or-nothing deal.
Precisely.
If one operation fails,
Uh-huh.
the whole thing gets rolled back.
As if nothing ever happened.
That's a relief. No partial updates, no data corruption.
Exactly. It's like a safety net for your database.
So how do we manage these transactions in EF Core?
There are a couple ways you
Right.
can manage them manually.
All right, give me the control.
You use begin transaction on your DB context.
Okay.
That gives you fine-grained control over when the transaction starts and stops.
So I can define those boundaries myself in code.
Exactly.
So I could start a transaction, do a bunch of operations, and then either commit them
Yep.
or roll them back if something goes wrong.
You got it.
But what if I don't want to handle all that manually?
No problem. EF Core can automate it for you.
Oh, good.
Any changes you make inside of save changes,
Yeah.
they're automatically wrapped in a transaction.
So I don't have to think about it for those simple cases.
Exactly.
But what about those more complex situations
Like what?
where a transaction needs to span across multiple DB contexts?
Ah, I see.
Is that even possible?
Absolutely. For that, you can use the transaction scope class.
Transaction scope.
It's like a master switch that controls all those operations.
No matter which DB context they're in.
You got it.
So even if I'm working with multiple databases,
Mm-hmm.
I can still ensure that everything happens consistently.
It's all or nothing, baby.
Right, transactions. Another crucial aspect of EF Core mastered.
We're on a roll.
This is great. We've covered so much,
The essentials.
but there's still so much more to learn.
There always is.
So we're going to take a quick break,
At your breath.
and then we'll be back to dive even deeper into the world of Entity Framework Core.
Can't wait.
All right, welcome back to our deep dive into Entity Framework Core.
Glad to be back.
We've covered a lot of ground already, but there's still so much more to explore.
EF Core is a deep well of knowledge. Definitely.
Always something new to discover.
Okay, so one thing that really caught my attention,
Yeah.
it's this idea of intercepting SQL queries.
Ah, yes, that's a good one.
It sounds almost like magic.
It's a powerful feature, that's for sure.
So what's the deal with this query interception?
It's like having this backstage pass, you know?
Yeah.
You
Yeah.
get to see those SQL queries that EF Core is generating.
Before they even hit the database.
Exactly.
So I can actually see the raw SQL that's being produced.
You got it.
That's pretty cool, but why would I want to do that?
Well, there are a lot of reasons.
Okay, like what?
One of the most common is logging.
Logging, all right?
You can log those queries for debugging purposes.
So if I'm trying to figure out why something's slow,
Exactly.
I can see which queries are the culprits.
You can see the exact SQL being sent to the database.
That's super helpful for troubleshooting.
It can really save you a lot of headaches.
What else can I do with this query interception?
Another common use case is auditing.
Auditing, okay. Let's say you have sensitive data.
Uh-huh.
You need to keep track of who's changing what. You can intercept those update and delete queries,
Okay.
log all the important details, who, when, what data was changed.
It's like having a security camera for my database,
I like that analogy.
capturing every move.
Exactly. And maybe one of the most powerful uses
Yeah.
is actually modifying those queries
Modifying them on the flow.
before they even get executed.
Okay, now that sounds interesting.
Imagine you have a multi-tenant application.
Okay.
Different tenants need to see different slices of data. With query interception, you can add those tenant-specific filters.
Without changing my application code.
Exactly. You're dynamically shaping the queries.
That's incredibly powerful.
It gives you a lot of flexibility.
It's like I'm a puppet master, controlling the flow of data.
You're getting it.
Okay, query interception, definitely a powerful tool in the EF Core arsenal.
No doubt about it.
Now, I want to switch gears a bit.
All right, what's next?
Let's talk performance,
Performance, always a hot topic.
especially when dealing with large data sets.
It can make or break your application.
Absolutely. So what are some key strategies for optimizing EF Core performance?
Well, one of the most important things to understand is eager loading.
Eager loading, I've heard of that.
It's all about avoiding those extra trips to the database.
The dreaded N+1 problem.
Exactly.
Can you remind us why that's such a performance killer?
Sure, imagine you're fetching a list of blog posts.
Okay.
And each post has a bunch of comments.
A classic blog scenario.
Without eager loading, you'd make one query to get the posts,
Right?
and then a separate query for each post to get its comments.
So it's like going to the grocery store without a list.
Haha, I like that.
You ended up making a ton of extra trips.
Exactly.
So eager loading helps me avoid those extra trips.
You got it.
But how do I actually use eager loading in EF Core?
You use the include method in your LINQ queries.
Include.
You tell EF Core, hey, load this related data up front.
So it fetches everything in one go?
Much
more efficient.
Like having that well-organized shopping list.
I'm starting to get hungry.
Haha. All right, so eager loading. That's one key technique.
What else can I do to optimize my queries?
Another powerful one is projection.
Projection, all right.
Instead of retrieving entire entities,
with all their properties.
you select only the specific fields you need.
It's like ordering a custom pizza, just the toppings you want.
Exactly. Less data to transfer, better performance.
Makes sense, especially for large data sets.
Absolutely.
Any other tricks up EF Core sleeve?
Well, it can also batch multiple operations together.
Oh, that sounds interesting.
So instead of sending multiple commands to the database, it bundles them up into one batch.
It's like a bulk discount.
You got it.
That must be a big win for performance.
Especially for things like bulk inserts or updates.
So I'm reducing those round trips to the database.
Minimizing the chatter.
Okay, what about those situations where I'm just reading data?
Read-only scenarios.
I don't need to track changes or anything.
You're thinking like a pro.
Are there any optimizations for that?
Absolutely. You can use the ASNO tracking method.
Exactly.
It tells EF Core, hey, don't bother tracking changes for these entities.
So it can skip some of that overhead.
Exactly. Less work for EF Core, better performance.
These are all fantastic tips.
Yes, scratching the surface.
So we've got eager loading, projection, batching, and ASNO tracking.
A good toolkit for performance optimization.
Any other general advice for squeezing that extra performance out of EF Core?
Remember your database indexes.
Indexes. Crucial for any database.
Make sure they're properly set up for your queries.
Helps the database find the data quickly.
Exactly.
Anything else?
And consider using DB context pooling.
DB context pooling, what's that?
It helps reduce the overhead of creating new DB context instances.
Okay.
Especially useful in high throughput scenarios.
So we're reusing those instances.
Exactly. Saves time and resources.
All right, so we've covered a lot of ground on performance optimization.
From code level techniques to database considerations.
But what about stored procedures?
Stored procedures, a classic approach.
Do they still have a place in the EF Core world?
Absolutely.
Okay, good to know.
They can be really useful for those complex queries.
Yeah.
Or when you need to leverage some database-specific features.
Makes sense.
Now, if you have a stored procedure that doesn't return any entities, you can execute it using execute squaw raw or execute squaw raw.
Execute squaw raw. So I'm sending raw SQL to the database.
Exactly.
Including calls to those stored procedures.
Yep, full control.
But what if my stored procedure does return data?
Data that I want to map to my entities, you can use from squaw raw or from Scunterpolated.
From squaw raw.
You
Interesting.
can execute the stored procedure and then...
And then it maps those results to my entity types.
Seamless integration.
So I can still leverage the power of stored procedures
Absolutely.
while staying within the EF Core ecosystem.
It's the best of both worlds.
This is all great stuff. We've covered so much.
From CRUD to performance to stored procedures.
It's been a whirlwind tour of EF Core.
And we're not done yet.
There's still more to explore.
Always something new to learn.
What else are you curious about? Well, one thing that I'm really interested in is migrations.
Migrations. Ah, yes.
It seems like such a crucial part of any evolving application.
Absolutely. Keeping your database in sync.
So let's dive into that in the next part of our deep dive.
Sounds like a plan.
Stay tuned, listeners. We'll be back soon to unravel the mysteries of EF Core migrations. All right, welcome back to our final part of this deep dive on Entity Framework Core.
It's been a journey, that's for sure.
So much to cover.
Yeah, but we've made it to the last stretch.
And I'm excited to wrap things up with a topic that's, well, essential for any app that's going to change over time.
You're talking about migrations, right?
Migrations, exactly.
Absolutely critical.
Keeping that database schema in sync with our application as it evolves.
Because things change, requirements change.
All the time, yeah.
New features, new properties, maybe even new tables.
Exactly. So how does EF Core handle all that?
Well, it's got this really cool migrations feature.
Okay, tell me more.
Think of a migration as a snapshot, like a point in time of your data model changes.
Okay.
You can create them, apply them, even roll them back if you need to.
So it's like version control for my database.
That's a great way to put it.
Each migration is a specific version of my schema.
And EF Core, it keeps track of all that.
So it knows what's been applied, what hasn't.
Exactly. So it knows exactly what needs to happen to get your database up to date.
That's pretty impressive.
Makes managing those changes a lot smoother.
So how do I create these migrations?
Do I need to write raw SQL scripts for every little change? Not at all. EF Core's got your back.
Okay, good.
You start by defining your model.
Like I've been doing with Code First or Fluent API.
Exactly. And then you use a command line tool.
Command line. All right.
It's .NET F migrations add.
.NET F migrations add. Okay.
And you give it a name, something descriptive.
So if I'm adding an email property to my customer entity, I'd run something like .NET F migrations add email to customer.
That's perfect.
And then what?
EF Core takes over.
It does the heavy lifting.
It looks at your model, figures out what SQL commands are needed.
Creates the tables, alters columns, drops things if necessary.
You got it. And it puts all those commands into a migration file.
So it's all automated.
Nice and clean.
That's awesome. But how do I actually apply those changes to my database?
Use another command.
Another one. All right.
.NET F database update.
.NET F database update. Okay.
In EF Core, it looks at all those migrations.
Sees what's been applied, what hasn't.
And it applies any pending migrations to your database.
So it's like a two-step process.
First, create the migration, then update.
Makes sense, but what if I mess up?
Oh,
Make a change I regret.
it happens.
Can I undo a migration?
Absolutely. You can roll them back.
Okay, that's a relief.
You use that same .NET F database update command,
The same one.
but you specify the target migration.
So I'm telling it which migration to roll back to.
Exactly. And it undoes all the changes from that migration and any that came after it.
So it's like hitting rewind on my database schema.
You got it. You have that safety net.
That's fantastic.
It's a powerful feature.
So I can experiment, try things out, knowing I can always go back.
Exactly. It's a great way to work.
Any other tips for working with migrations?
Keep those migrations small and focused,
Okay, small and focused.
instead of lumping a bunch of changes together.
Yeah, I can see how that would get messy.
It's better to create separate migrations for each logical change.
Easier to track, easier to roll back if needed.
Exactly. And it makes understanding the history of your schema much clearer.
Makes sense. Anything else?
Think about data seeding.
Data seeding, okay.
Sometimes when you change the schema,
You need to add some initial data.
or maybe update existing data,
Right, so the database isn't just structurally sound.
it's also got the right data in it.
So EF Core can handle that too.
As part of your migrations, you can seed data.
That's convenient.
It's all about keeping things consistent.
And if I'm working on a team,
Collaboration.
we need to be careful with migrations.
Absolutely.
Make sure everyone's on the same page,
Everyone's got the latest migrations.
especially before we push to production.
Crucial for a smooth deployment.
Okay, so migrations, super important for managing those database schema changes.
A key part of the EF Core workflow.
This has been an amazing deep dive.
I've enjoyed it.
We've covered so much.
From the basics to some really advanced topics.
It's been a whirlwind tour of Entity Framework Core.
And I hope our listeners feel more confident in their EF Core skills.
I think they definitely should.
It's a powerful tool.
It can really simplify data access in .NET.
And with a little practice.
Anyone can master it.
So keep learning, keep building, and keep exploring the world of EF Core.
Thanks for joining us on this deep dive.
It's been a pleasure.
And until next time, happy coding.